Hello, it's been a long time since I last recorded the video. There hasn't been a whole lot of update, but some good progress, I think. Since the last update when I started working with SDL3 GPU, I've managed to implement the skybox. There's a simple terrain mesh. Mesh is generated using compute shader that reads the texture data from a DDS file and does the vertex displacement. And I am now kind of settled on just using DDS files for all texture and height map data. In between, I did write a TGA parser, target files. I wrote a TIFF parser, but it turns out both of those were completely unnecessary because I can just use the GPU to generate the terrain, or at least read the height map data. So what does it all look like? Let's see. Let's see. There we go. So here you can see there's a skybox, there's little test cubes, and then the terrain. This is a height map of the Mount Fuji area. It's 1024 by 1024 texture, and then the mesh is equally 1024 by 1024 units long and wide. The wireframe shown here is generated using the shader, fragment shader, but you can see like none of the vertices are optimized. It's just a sheer soup of triangles going all the way to the edge. Yeah. I mean, despite not being very well optimized, it still seems to render pretty well. But again, for a modern GPU, this is not a whole lot of triangles, so that's good. You can see here, if we look at the output, kind of gotten some colors there with the logging. And I'm rendering stuff out with its shaders, so kind of give you some tour of how it's set up at the moment. And I'm going to change a whole lot of this as time goes on. But let's see, can close this. So what I have done is, this is my pipeline descriptors. It's pretty straightforward pipeline descriptor, but it's going to change. It loads the shader files that I have. It generates a sky mesh. It's a dome. It's a sky dome that's been subdivided 4 times, and it uses a cube mesh, or sorry, a cube map texture file, the skybox cube map. If I show it here, let me open it. It's not a very complicated cube map. It's very basic. Each side is only 512 pixels wide. See. Okay, as you can see. All right, pretty simple cube map. I haven't done anything special to it. Similarly, terrain. I have vertex and pixel shader for the terrain, and it uses the Mount Fuji height map. So this is it. It's 1024 by 1024. This is Mount Fuji in the middle, and then the surrounding area. Okay. The mesh itself is just a set of pairs of triangle repeated 1024 times, and each corner of the triangle is sampled from the vertex, or sorry, from the fragment shader. And then the displacement is calculated by the compute shader. So if we go in here to the compute shader, and all it does is it reads the UV coordinates that I have put in to the height map, or sorry, to the terrain mesh, and just does a sampling of it and stores the sampled value with some scaling into back into the memory. And then the vertex shader just blindly reads it. Pixel shader just draws it. And then I have this here that this is what's actually drawing the wireframe in the pixel shader. If I were to disable it, it's kind of pretty simple to do. You get a terrain without a wireframe, which looks pretty good. Right. Let's go back to that. Right, so that's the current state. Plan for the next stage is to update the render logic. And part of that is because if you look at how I'm doing the rendering, it's not very good. I don't really like it, because what I've done, so I have 3 different textures, right? There's a texture for the cubes, the test cubes. There's a texture for the skydome and a texture for the terrain. I read them all in. I have an add texture function that takes those 3 textures, but it only takes those 3 textures. And the same thing applies for the pipelines and for the meshes. And then once all of them have been added, they get uploaded to the GPU. So I did discover that there is an upper limit to how large the transfer buffer can be, and I was kind of hitting that limit with the data I have. So I've had to split it up into 2 different transfer buffers, one for the mesh buffer and the other for the texture buffer. And all the rest is pretty much the same, but it's not very configurable, right? Because you have to do things in this order, otherwise it won't work. If for whatever reason I don't want a terrain, or I don't want the sky dome, or I don't want any of the test cubes, it will fail, basically, because it always expects those things to be present. These checks, these if statements don't really do anything, because it's always available. Similarly, when it comes time to drawing, right, they get drawn in order. But again, all of this, there should theoretically be no difference between how I draw the mesh and how I draw the terrain, because they're both meshes. Similarly, there should be no difference in how I create the pipelines for both of this, all 3 of these. So if we go into the pipeline, you'll see I have a mesh pipeline, skydome pipeline, terrain pipeline, but again, this seems unnecessary. The other important bit I want to change, and this is in preparation for adding level of detail for the terrain, so it's a slightly more performant, is right now I'm using compute shader to calculate the displacement, but you can do the same thing with the vertex shader, and there are several techniques. The two that I've come across, one is called the geometric micmap, and the other is called the continuous distance dependent level of detail. Both the continuous distance dependent level of detail depends, or rather builds on top of geometric clip map technique, and they're both seemingly simple to implement. So that's my next plan, is to try and implement one of these techniques, as well as add in some sort of terrain texturing, because right now I'm just drawing the terrain with the height map that I have, but that's not really ideal because the height map is just black and white. So that's gonna have to change. But so the next video I do will probably be once I have completed these items. Yeah, that's it for now.